Hypothalamus artificial intelligence, HI. Digital transformation powered by real-time autonomous and intelligent algorithms. Presents the short conference. Conference prepared and edited by Jesús Velásquez-Bermúdez. His resume may be found on LinkedIn. What's the difference? Full truckload shipping versus less-than-truckload. Less-than-truckload, LTL, transport networks. An LTL network consists of the following entities. Load, it is associated with the problem of local collection and delivery, from the loading site to a terminal of the LTL network. It is not considered in the LTL network since it is assumed to be part of another process. End of line, EOL, it is the origin or destination of the cargo. Therefore, for each end of the terminal line it is the hub, center, closest to the loading/unloading site that is considered as the origin or destination of the loads. Break bulk, HUB, terminal where unloading, sorting, and loading from one truck to another is carried out. Hubs connected to a certain primary point are called satellites. Terminal, HUB, terminal where unloading, sorting, and loading from one truck to another is carried out. Hubs connected to a certain primary point are called satellites. Less-than-truckload, LTL, transport networks. Challenge, to develop a DSS to support LTL, less-than-truckload trucking, business of a transport broker. The central problem is to choose the most profitable transport service demands, for direct long-haul routes or for multiple pickup and delivery routes, and fix the offer price for requests for transport services or accepting an offer previously agreed in a long-term agreement. An LTL network is made up of a transport company with a fleet of trucks, which serves a sequence of delivery requests, received either by phone, mail, or internet. Solution: design a DSS for LTL revenue management that must have the following models. ML-like models are used. Demand winning bids determines SVMs, support vector machines, to segment winner bids of prices offers to charge to load generators. Supply winning bids determines SVMs to segment winner bids of prices offers to pay to the transporters, and link LTL network dispatch and revenue management including the SVMs that defines the winning frontiers for price offers. Result: proposal showed to potential client jointly with a business partner to implement the DSS for an LTL operator. The figure features an illustration of the LTL trucking operation network. 12 end of lines, 5 hubs, 36 loads, and 11 trucks. The central problem of an LTL broker is to choose the most cost-effective demands for transport services, direct long-distance routes or multiple pickup and delivery routes, and the fixing of the offer price for requests for transport services or the acceptance of a previously agreed offer in a long-term agreement. An LTL network is formed by a transport company with a fleet of trucks, which attends to a sequence of delivery requests, received by phone, mail or internet. The solution is to implement a DSS for LTL revenue management that must have the following models. Winning price bids to charge for serve load transport generators, determined by machine learning, ML, models to segment the space between winning bids and losing bids. Winning price bids prices payable to carriers, determined by ML models to segment the space between winning bids and losing bids. Link the flow through the LTL network with ML models for revenue management that define the winning frontiers for pricing offers. The figure presents the environment of an LTL broker. On the left side are presented the demands that must, or can, be met, and the demands satisfied. On the right side, the available trucks and the capacities used are presented. The central problem of an LTL broker is to choose the most cost-effective demands for transport services, direct long-distance routes or multiple pickup and delivery routes, and the fixing of the offer price for requests for transport services or the acceptance of a previously agreed offer, in a long-term agreement. An LTL network is formed by a transport company with a fleet of trucks, which attends to a sequence of delivery requests, received by phone, mail or internet. The solution is to implement a DSS for LTL revenue management that must have the following models. Winning price bids to charge for serve load transport generators, determined by machine learning, ML, models to segment the space between winning bids and losing bids. Winning price bids prices payable to carriers, determined by ML models to segment the space between winning bids and losing bids. Link the flow through the LTL network with ML models for revenue management that define the winning frontiers for pricing offers. The diagram on the left shows the trips of the trucks, red, while the one on the right shows the differentiated trips loaded, blue, and unloaded, green. The diagram on the left shows the trips of the trucks, red, while the one on the right shows the differentiated trips loaded, blue, and unloaded, green. To be solid, the decision-making process implies that when selecting an RS request in an OLH, the broker must analyze what could happen in the following OLHs, simulating what is the decision in the next destination that will happen. This would be called multi-stage decision, which extends the pricing model from a single route to multiple routes. Therefore, the transport problem involves multiple trips, with allocation of quantities and routes, that represent the requests. From the allocation, travel costs and expected benefits are determined. Restrictions such as receipt and dispatch service windows, time windows, arrival time of vehicles in travel, restrictions on LTL applications according to vehicle type, simultaneous analysis of transactions in multiple hubs, OLH, and analysis of collaboration between participants. Therefore, a model to participate in the LTL market must be large-scale and will be based on fundamental models such as VRP, Vehicle Routing Problem, and TSP, Travel Salesman Problem, including variations according to the state-of-the-art and representative modeling of the real world, for example, dynamic travel times dependent on departure time. One of the foundations of machine learning, ML, are the support vector machines, SVM, that have their origin in the works on the theory of statistical learning introduced in the 90s by Vapnik and his collaborators. Although SVMs were originally intended to solve binary classification problems, they are currently used to solve other types of problems, regression, clustering, multi-classification. Since their introduction, SVMs have been gaining well-deserved recognition thanks to their solid theoretical foundations. Next, we will analyze the case of using SVM to support the broker's decisions that require characterizing and/or discriminating successful offers. The business was given, from unsuccessful ones, which implies segmenting the offers between success and non-success. The problem from the SVM point of view is to separate the space by a hyperplane that divides the offers between success and non-success. In this case, the methodology of the support vector machines divides the multidimensional space into two parts, success and non-success. The broker's offers, whether buying or selling, are stored in a database. If the offer is for purchase, for example, how much to pay for the rental of a truck, to serve a customer who requests a service characterized by weight, volume, route, type of load, and other parameters. The database can store data from the broker, as well as from competitors. The result of processing the database will be the price to be offered for rent the truck. Based on the natural mental model, the buyer will try to offer the lowest possible price, which gives them the opportunity to win the business while also maximizing its revenue. However, if the price falls to zero, the broker will not make a profit, and if it stays too high, the chance of winning the purchase decreases. Using SVM, the broker can set the maximum price limit that produces winning bids, and using an operating model, which simulates the process of using the truck, set the minimum price limit to have a profitable bid. In this price range is the solution for the price. The problem with SVM is to select from an infinity of possibilities, the one that is considered the best to divide the multidimensional space. Any of the group of methodologies based on the concept of SVM, select a hyperplane to divide the space in such a way that each point of the sample is on one of the two sides. The methodology to be used may vary with the type of problem. There are infinite numbers of hyperplanes that can separate, segment, winning bids from losing ones. SVM allows to determine the optimal hyperplane as one that maximizes the distance from the closest point of each group to the support hyperplane, vector. Until now, the idea has been assumed that the sample objects were separable or quasi-separable, and therefore hyperplanes were defined as linear functions in the space of objects. Now, we describe how to use nonlinear base function sets to define high-dimensional transformation spaces, and how to obtain optimal separation hyperplanes in such transform spaces, which are called feature space, to differentiate it from the space of input objects. To do this, the original mathematical characteristics of objects must be converted into transformed features based on one or more kernel functions, kx, which can lead to expanding the number of features to be considered in objects. The model maximizes the expected value of the broker's profits for all trips originating from any node in the LTL network. The decision to make an offer, or not, is a subjective process in which there can be multiple criteria. The rule is bid only if the offer is classified as successful. Conceptually, it must have the following models: SVM DEM, SVM OFF, winning bids, ML model that determines SVMs to segment chargeable prices to load generators. SVM OFF, winning bids, ML model that determines SVMs to segment payable prices to carriers. MaxRM, dispatch of the LTL network and revenue management, contains the dispatch model of the LTL network and its link with the income of the broker. The diagram presents the connectivity of the three mathematical models. The SVM models feed the MaxRM model that simulates the operation of the transportation network, determining the balance between supply and demand, and optimizing profitability. The results are: prices purchase transportation services, prices sale transportation services. MaxRM maximizes the expected value of the broker's profits. The decision to make or not to make an offer and determine its value is not a subjective process in which there can be multiple criteria. As a condition of the business, a rule is included that limits offers to those that are classified as successful. The constraints of the MaxRM model are grouped as follows: revenue, equations representing revenue and operational expenditures. Travel assignment, restrictions on vehicle capacity and service assignment to vehicles, corresponds to the system of equations WXR equals 0. Offer sale, restrictions of coordination of the offers of sale of services, correspond to the equations that coordinate the offers with the equations WXR equals 0. Purchase offer, coordination restrictions of service purchase offers, correspond to the equations that coordinate the offers with the equations WXR equals 0. DEM support hyperplane, SVM, DEM of the sale price, corresponds to the equations SVM DEM, X, R. Off support hyperplane, SVM, off of the sale price, corresponds to the equations SVM off, X, R. Other restrictions, business rules. The image presents the reduced formulation of the problem. Like Herbert Simon, Hypothalamus artificial intelligence believes that computer-based mathematical modeling is the greatest invention of all time. Thank you for your attention.